because the doctor didn't give us any idea what happened or why she's sick. And so we found out this they did cultures overnight. So she's still at home, crumpled in a bed. So now she can have like.
Sir, do you like my style like this?
That'd be scary.
Yeah, well, yeah, because I didn't know at first. I was like thinking the worst, like she has kidney failure or something like that. So my wife went to hospital
Just that.
from work. I got called here at 3:15 to go to emergency room. My wife's like not reacting. So she's crying in bed.
He plays basketball?
Yeah, she had kidney infection. She didn't get antibiotics. It feels like being shot in the back.
Didn't he say you wanted to do
Are your scars the other day?
Lord, should I finish my test today? I will be tomorrow.
Yes,
Okay.
right now. You can go to the back.
Is it here now?
Yes, sorry. Yeah, you can take that off. Sorry. That was for geometry. I was going through the notes.
I'm gonna go.
Back. That's it.
I finished my test.
Now, it should be quiet. We're just going to do a couple minutes.
You actually know that?
Hi, Ward.
Tap, do you need to finish yours too?
I don't know if I do or not. I'm not sure.
Go to the back. Go to the back and act like you need to finish it right now.
Act like I need
Yeah. So I'll put you in the back. I'll give you your test.
Oh, we're doing sit or doing
Just.
Go
Someone
sit.
asked someone look him up and
What happens if I'm really done with that? I just get it and give it back?
Yeah.
Okay.
not like the fighters here like that.
Where's that?
I'm like this right
That's
here.
like the day.
Oh my god, I made that tweet.
Okay. Sometime next week we'll have you.
Oh, Saturday's coming up.
I don't know if you're going to be ready.
I took all tests last night.
I saw everybody talks about that.
Do it fast.
like the new one.
No, really don't.
He's running it up.
All right.
I don't have enough room.
Is it on your screen? Like, does it show up?
Okay. So.
Building a cushion.
Okay, today, ignore this, that's not what we're doing. We're gonna just talk about some factoring today. That's it, just a couple notes. We'll be done pretty early here. I just wanna make sure we get an intro into something. The first couple classes today, they didn't go through anything, so I'm not gonna go too quick. Today, we'll finish it up. We'll finish up our stuff tomorrow. Alright, so let me get rid of this. Okay, pretty basic, just to let you know so you guys are aware of it. I am recording your guys' class today. Because I didn't have any class to record this morning. They're all taking ASVAB, so. Alright, let's put it right there.
In here?
Yep. Alright, so.
Wait, so is it recording now?
Yes, so. Alright, so section.
Good camera.
Hey, quit it. Alright, so P.5, we're on factoring. Okay. So factoring is a big deal for us. This is going to be a majority of probably the problems that most people will have later on in these sections, is that you just will get confused on how to factor things apart. And that's something that we just need to discuss to make sure that we're good at. So the idea here is that there's a couple different types of factoring. We're going to try to practice these today and tomorrow. So one of the types of factoring that we're going to be covering here is going to be just common factors. Okay, so we're going to be doing common factors. That's just, if you looked at your problem, it could be a binomial, trinomial, it could be anything bigger than that. You just notice that every item has something in common. So something like this. Let me give you an example. Okay, something like that. Well, when I look at that problem, they all have roughly a 5 in common. You know, they don't have x's or anything, but all of them have a 5 in it. So you can pull the 5 out before you start. That's a common factor. That takes skill. That just takes like visually looking at that thing and knowing what do you see first. Okay, so that's gonna be one of our first thing we'll do. We'll practice this problem. We'll try another one with like variables in it. Okay, the next thing we're gonna try. We're gonna do the trinomials. Okay, the trinomial's pretty basic. I don't have you do that thing where you memorize like the perfect trinomial square. That's stupid. I don't do that. I just give you the rules for how do you factor any type of trinomial, because then you can do it every single time. So I'll give you those basic rules. We're going to talk about those. I think this is probably where we'll end today. We'll end there. Now the other types that I know we're gonna cover in here. I know that we're going to eventually get to difference of squares. That'll be one of our types. Difference of squares is actually a type of trinomial. A lot of people don't realize that. So it's actually, it follows the same rules I teach you earlier. One of the rules we'll eventually get to is the cube rule, how you factor cubic functions. So we'll look at that. And then the last type, which is pretty much the most difficult, not difficult wise in like problems, like homework, but just difficult to teach because it's open-ended. I can't prepare you for every type, I can just give you the gist of what you're looking for, is called grouping. Grouping factoring. So how you look for something to group together. And that's a different style. We'll probably finish those types up tomorrow. My goal today is just get to the top two. Okay, that's what I want to get through. Then tomorrow we'll do the next three. Okay, we're not going to get homework tomorrow. I'm just going to do notes. So you'll have kind of a weekend where you can kind of relax. Okay? All right, is there any questions with what I want to cover the next couple days in here? This is a major concept. I know that this is something you talk about in Algebra 2. It's like Chapter 3. It's like the second half of Chapter 3 in Algebra 2. But I just want to make sure that we are comfortable with this, because this is something we'll have to do on a lot of problems just in the middle of a problem. So, I mean, it's just something you just will do so many times, you just have to get used to it. So, we're going to start with the common factors. We'll do a couple of those. Maybe we'll do 2 or 3 of them. And then we'll move on to trinomials, where we're going to spend the rest of the time. Okay? We good with that? Okay, so what factoring is, just so you realize, it is not foiling, it is not distributing. Okay, factoring is trying to pull this thing apart. Trying to get back to where things are being multiplied together. Going back to like the original problems like we looked at the other day where you have something times another object. Or it could be you're pulling something where there's just going to be an item on the outside and it's being multiplied on something in a parenthesis. Because that's what mostly common factors are, is this. It's just like a scalar or an algebraic multiplier. But it's going back to the original problem. That's how I think of it. It's just going backwards. So when you do this, it's kind of like you're dividing. That's really what you're doing. You're dividing things out. So what you need to realize, when you look at this problem, you compare each monomial separately, because there is 3 of them. It is a trinomial. You compare each of them separately. What do they all 3 have in common?
5.
5. Okay, so we pull that out. So, alright, so you pull a 5 out. So, when you divide this out, and you're taking the 5 out, there should be 3 items left in here. How I know that? If there's 3 items to start with, there better be 3 items in that parenthesis when you do common factors. That's something that you don't realize some people make a mistake on. They make the mistake right there. They don't realize it's supposed to be 3. Okay, so factor out the 5, what do we have?
5. X to the third.
X third, right? It's actually a 1x to the third. The reason why it's a 1, you're taking this number and dividing it to there, right? 5 divided by 5. 15x, take out a 5. 3x. Because you're dividing the 5 out of it. Okay? And then the last term,
-1.
minus 1. And that's the part most people get wrong, especially if this is a plus. Some people think that they just drop it off. You know, it's not there anymore. Oh, I took the 5 out. No, you divided it out. So there is still a 1 there. Okay, is there any questions with that? Now, if you do this, you then have to look at what's left in here and see if you can go further by those other rules, like trinomial rule, cube rule, that type of thing. Now, this is not a trinomial. Trinomials typically have a square, a normal x, and then a number, right? So it goes descending order. This is not descending order. So this would not be a trinomial. Okay, any questions with that problem? I know that's an easy one, it's simple, it's stupid, but it at least gives you the gist of what we're doing here. Okay, let's do another problem where we have variables in it. So let's do something like 12x squared y minus 16xy to the 5th z. Yeah, we'll stop there. We'll do a binomial. Okay? Alright, so on this particular problem, what we need to look for first is that it's a binomial, and we have to look, is there anything that they both have in common?
Least common multiple
Least common multiple.
is the
Okay.
4x.
Okay, so I agree that
Why?
in here we're gonna have 2 items, right? We're gonna have 2 items. It'll be a minus sign in the middle because we're gonna be taking out items here now. We're taking out what? A 4, an x, and a y. Okay. Now here's y. Okay. Hey. So the 12 here and the 16. When you look at numbers that multiply to give you those, 4 is the biggest number that they both have in it. So it's still kind of looking at like the factor tree for these, but for me, it's easy just breaking them down where different numbers are multiplied to give you 12. 1, 2, 3s, 4s, 6s, and 12s. On 16s, it's 1, 2, 4, 8, 16s.
Yes, sir.
And so the biggest number they had was a 4, so you're gonna pull that outside. Then for the variables, you have to look at the letters and see how many they both have. They at least have one x. And then when you pull out the y, they both have at least one y. And then the z is only on the one, so I don't worry about it. But this is how you do it. You look at what each of them have, and I pulled it on the outside. Then what you do is on the inside, what's left is you divide this by what you took out. That's what I'm doing. So what I'm doing right now is I'm taking 12x squared y, and I'm dividing by a 4xy. And that number goes here. So what's 12 divided by 4?
Well, it'd be a 3. X.
Yeah, so the x will go away on the bottom, we'll take away 1 from the top, and the y's are gone, right?
3x.
So it'll be just a 3x there. That's what's left when I actually do this.
Yes.
And I know that's a mess, but I mean, that's literally what you're doing. You're dividing that 4xy out. Now for the 16, same exact idea. I'm taking the 4xy out of that thing, and you're dividing it out. So 16 divided by 4, that's
It'd be
4.
4.
X is out, y, it'd be what, 4 y's left over, and a z, because I didn't pull that out. So it's basically like for the variables, you're subtracting the variables out. That's kind of what you're doing. Alright, any questions with that problem? Now, in what's left in here, what's left in this, you'd have to go further later, but you have to pull a common factor first.
Do you have to put the 4 out there, or can you just?
Nope, you gotta put, it's gotta sit on the outside. Yeah, it has to sit out there.
I'll give you credit.
Okay, do we need to go through any more examples of this type of problem?
No.
Okay, now, if they don't have anything in common, you can't do this. Like, if, let's say I was doing this problem and there was like, this is a 51 back here, like, it's not even a number that these have, then that's your answer, like, you couldn't factor it apart. So it's just, whatever they have in common, that goes on the outside and you have to leave it there. I'm going back to what the original problem should have been before you multiplied. That's what I'm thinking about. Okay, so now, the rest of today is going to be focused on the trinomials. There's a one subtle rule that I'm going to try to teach you for this. And I know some people, they like it when they see it. I don't want to confuse you about it, but this is the way I think of it when I think of trinomials. So and for most people that I usually show this, it usually makes sense and they like it a little bit more than just trying to wing it. Okay? Alright, so this is what I mean by a trinomial. Let's go this. Let's put 4 back here. Okay, that's a trinomial. It's 3 items. It is descending order. You know, there's no missing terms there. There's nothing in common, because that's what I would try first. I always try common factors first. Okay, so we're going to break this up into 2 parentheses, like before. There's no common factor here, but this is our goal, is to make it into this, where we're going to make 2 binomials here and here. Okay, we're going to try to make a binomial and a binomial. Okay, so that's our goal. That's what we want to get to. So there's a subtle rule that we do, and this is how I always think of it. When I start the problem, I make sure it's written in descending order first, number 1. Next, I look at the symbol in the back. This tells me a lot. That's the first thing I look at. I don't look at the numbers, don't look at the variables. I look at that symbol. That symbol is telling me that the operations that are in here, these things that are in here, are going to be the same. That's what the plus sign back means. If that was a minus sign back there, like this, then I know that if it's a minus sign, the operations that are in here are automatically opposites of each other. That's what the minus sign in the back means. They're opposites versus they have to be the same. Okay, so here, if they have to be opposites, I have to put a plus minus. It's forced that way. That's what I look at first. If up here, if they're going to be the same, you have to look at what's in front. This is what they are. They're both plus signs. That's what that front symbol tells you. If that was a minus sign, these would both be minus signs. Does that make sense? They have to be the same. Okay, does everyone understand rule number 1?
Yes, sir.
Okay? Rule number 2
Okay.
on this is you need to break up this item and put it here and here. And usually what I do is I just break it up evenly, if there's not a number there. So, how do you break up an x squared? It's
Put x.
x and x, right? So, that's easy enough. Now, if there's a number out there, now this problem's way more difficult. And I'll try to walk you through that. Okay, in the back is the back item. That's all I'm doing. I'm breaking up the back item and putting it in the back of both parentheses. And when you're doing this, you just have to make sure that you somehow make a number, or two numbers, that multiply to give you the 4. That's all I'm thinking about. Okay, so you're multiplying to give you 4. So there's a couple options I can put here and here. It could be a 4 and a 1, or 1 and 4, it could be 2 and 2. Okay? But you need to make sure that you're multiplying to give you the 4, but they have to add in the middle to give you 5. So it is 1 or 1 or 1 and 4. It doesn't really matter.
You know that's adding?
Okay.
What?
Does that okay? Does that make sense to everyone?
Piece of cake, isn't it?
Okay. All right. Now, it gets more difficult when there's numbers out front, because now this number and the back number both affect each other to make the middle term. It's not just whatever the back number is. So that's the part where I don't have a rule for it. It's all trial and error until you get it right. And I'll just kind of walk you through how I process
You
it.
just wing it?
It's pretty much just winging it.
I just have to wing it.
Well, we're gonna have to if there's a number up front.
Okay.
Okay, now the minus sign in the back means it's automatically plus minus. You still do the same rule. The x and x are out front, because that's the front number. The back number still goes back here. But now when you have this symbol, now it does matter where you put them. That's the difference. Like out there, it didn't matter. You're gonna get the same number anyways, they're adding, right? But when they're opposites, they have to either add or subtract to make the middle. So on this particular problem, I need to make sure that I make a positive 3 in the middle. Positive 3. And I still need numbers that multiply to give me 4.
Probably at 4.
So it's gonna have to be a 4 and a 1. Because that, if I multiply these together, I'll get a negative 4. But when I add this and this, it gives me the positive 3 in the middle. Because what I'm doing is I'm foiling it out in my head. Like, I know that this is my answer, but in my head I'm going x times x, x times the negative 1, 4 times the x, and then 4 times the negative 1. And so I know that it's going to make the 3 in the middle, so it is correct. But when you factor, this is what I'm looking for. This. That is the whole point of factoring. Why that's important. Like, why are we looking for parentheses like this? These are the answers where this object, if you were to graph it on a graphing calculator, or graph it by hand, these objects, and if this thing was equal to 0, these objects are where that graph will hit the x-axis. They're giving you your x numbers. So if this thing was equal to 0, because that's how you do it, the numbers that would make this thing equal 0 would be negative 4 or a positive 1. Because how I do that, you set this parenthesis equal to 0, this parenthesis equals 0, because I don't know which parenthesis is 0, because when you take 0 times something is 0, or 0 times something is 0. So these two numbers are where this graph would hit the x-axis. In fact, this graph is actually, what we're going to learn eventually, is this graph's pointing upwards. It's hitting negative 4 on the x-axis, it's hitting positive 1, and it's bowing upwards. That's something we are going to discuss this year. Like, how do I know that? Where is it going to be? Where is this bottom point going to be? It's called a minimum number. Okay? That's something we're going to look at. Why does it face upwards? That type of thing. That's why this is important. Factoring is the start of graphing stuff. So this goes really well with chapter 1 material. So I mean, that's really what we jump into. Chapter 1 is all about graphing. We'll teach you the basics of graphing. All right. Any questions with factoring right now? Okay, let's try a couple more of these where we have different rules and stuff. We try different numbers. Okay? All right. Let's go with the basic term here. X squared plus, let's go 18x plus, let's go 77. In fact, I'm going to make this a minus. Alright, so, first thing we do they have anything in common, all three of them? No. Next thing, step 2, we break these up into two parentheses, and we see if this works. So, what are my symbols gonna be? Well, they're gonna be the same, whatever they are. They're both gonna be minus signs. So this means that they're gonna be the same, they're both minus signs here and here. Okay, does everyone understand that first rule?
Yes, sir.
I always think of the first rule before you start. Okay, step 2, we break up the x squared. So breaking up my x squared here in the front, that has to go in the front here, so it's x and x. And now we're gonna break up 77. Well, there's only a couple options for 77. 1 and 77 or 7 and 11. That's the only options, because they're prime numbers. So now, I need to know where to put them. Does one of the combinations make 18? Yeah, which one? 7 and 11, right? And it doesn't matter where you put them. The reason why it doesn't matter is because they're both the same symbol. Okay, now, let's do one where it does matter. So we're gonna go, let's go x squared minus 13x minus 36. Okay, so, again, like before, we do two parentheses. Because they don't have anything in common. I mean, that's a prime number, so I know that the only thing they have is ones. Now, what are my symbols gonna be? So we look at the back. It has to be a plus minus. Has to be. Because the minus sign in the back says they're automatically opposites. Okay, so now that I know that, now I can break the x squared in the front. So that's my front number, right? X and x. And now I have to break up the back number. So there's a bunch of options for 36. There's 1 and 36, 2 and 13, or sorry, not 2 and 13, 3 and 12, 3 and 12. You could go, what, 6 and 6, 4 and 9. But what option gives us 13?
9 and 4.
9 and 4. And now, here's the problem. Will it make 9 and 4?
No.
No. Because these are opposites.
Oh,
Right? If you try to put 9 and 4, so that's why I made this one. If you try to put 9 and 4, because everyone's like, oh, 13 is 9 and 4.
Unfactorable.
It's a plus minus sign. When you actually put them together, you just got 5 x's, not 13, because one's a positive, one's a negative. So you're thinking, okay, it's not 4 and 9 now because it's 5. So I try, what is that, 3 and 12? Didn't work. That would, if I were to subtract 3 and 12, that would give me something like 9. What is the other number? 6 and 6. 2 and 18. So none of those numbers work. So this thing is what we say non-factorable. So non-factorable, I'll just put NA, does not exist, something like that on my paper, just to show like I can't factor it. I know some people just say non-factorable, that's fine, you can just put that, okay? But I wanted to just show you that problem, because I know when people look at that problem, they automatically think 9 and 4, without even thinking about for 2 seconds what those symbols were. The plus minus sign meant that they're opposites. What would have made this problem different is if I just had a plus back here. Now it's good to go. If that was a plus, then both of these are minus signs, and now you can do 9 and 4 all you want, because now it works, because that would make 13 now. You see how subtlety in symbols can make the difference? Alright, let's do one more problem. That's what I want to end with one more. I want to do a problem where we put a number out front. Put a number out front. Okay. So we have a couple minutes. We'll be done here. Okay. Alright, let's see. 2x squared. Let's see, plus, let's see, 4x minus, let's see. Okay, first step. do you think?
Put your parentheses.
You have to put two.
Ah, haha, okay.
Two X
So,
and X.
there's two ways of doing this problem. Most people think that you can go this route, do the two parentheses, you go plus minus, then you go the 2x, x route. It's too hard, you've already broken it. The reason why is before you started, take out the 2. Take out the 2. So, if you take out the 2 first, now it makes the problem easier. Now you don't have to deal with that number up front anymore. You can, don't get me wrong, it'll still be the same answer. It's just, I like to take out the 2 first, and then we can factor this later. So taking out the 2, I'll have an x squared, a 12x, and a 45, negative 45. And now, we can break this up. Now we can go even further here. Okay, so factoring this apart even further, use blue. So this will be 2 parentheses now, and I'm just gonna leave the 2 out front, that doesn't make any difference. It'll be plus minus, it'll be x and x, and now I gotta break up the 45. We have 9 and 5,
Plus 15.
15 and 3, yeah, that'll have to be it, and so I'm gonna go to plus 15 to minus 3 route. That'd be your answer. So cross country, if you guys need to go, you can.
What time did you guys run?
Okay. Now, if you were that person that did not factor out the 2, you were that, you didn't see that, you didn't even think about it, because, you're distracted by whatever problem you're working on, you would still get the same answer as somebody else, okay? You could still factor the thing apart where it's still plus minus. You could still go, you could go 2x and 1x, and you could go, what is this? You could go, let's see.
It's hard.
Let's go minus plus. This could be a 6 and a 15. So 6 and 15 make 90. And then if I made sure this is plus minus, because if you foil this out, that would be a 2x squared. Geez, that's a terrible 2. 2x squared. 2 times 15 is 30. X. 6, so that's minus 6x. And then a negative 90. And so this would combine to make 24, right?
Wow.
So, now, here's the thing. It's still the same problem I did earlier. Because if you look at the original problem here, let me go back to this. It's still the same problem because do you see that the 1x plus 15 is still over there?
Yes.
And all they did was take the 2 and distribute it to here. That's all they did. So, it is still the same problem, it's just, it makes it way more difficult
So that's
when the
same
number's
answer.
out front. They're the same problem.
So
Preferably,
you like that?
this is the best way to do it. You always take out common factors first. It makes numbers smaller, easier to work
You
with.
always
What if there
never
are
do
no
that?
common
Yes.
factors?
Yes,
Always?
well, not always. If you put like a 7 out here and there's 7, don't go in the back. But I'm saying like, for the problems that we typically get, yes, there's always a number that comes out.
So
And that
could
makes
that,
it easier.
And it's
could that be the answer?
Yes, that's the answer I want. I don't want this one.
So
Oh,
it'd be-
that one is factored completely.
So it'd be 0, negative 15, and 3?
No, it would just be, this doesn't count, there's no variable out there. So it'd just be negative 15 and a positive 3 for roots if you were graphing that thing. So if I were to graph this thing, it would go through at negative 15 down the road and positive 3 and it would look like this. If you were to graph that. The only reason why 2 didn't matter is because 2 didn't have a variable on it. You only solve it when there's variables on it. Questions? What I'll do tomorrow is